a function y is equal to 5x into 2x squared minus 1. Input 4. So this function here can be seen as a product. Can anyone tell me why we can look at this as a product?
So because we can multiply, remove the brackets.
Yeah, well, that's when we apply the product rule. We can fit in this case, but why would we call this a product? What is indicating that some form of multiplication is happening?
Sort the brackets.
Great, great. So in this case, we can take 5x as a separate function. We'll call this function u, and 4x squared minus 1, we'll take this function and call it v. So we're looking at y is equal to u multiplied by v. So we can look at it as two separate functions. Is this clear with everyone?
Yes, sir.
Yes, sir.
All right, so basically what we say for the product rule, and I want you to make a note of this. This is how I remembered it all those years through. If we have to differentiate a function using the product rule, we say differentiate the force and leave the second. Leaves the second. Right? So if you remember this, you essentially have the product rule in your hand. You differentiate the force, you leave the second. Are we good so far?
Yes, sir.
Now, when you're doing the product rule, this is what you want to do. The product rule is equal to, if we're differentiating the force is u, then I'm leaving the second, so I'll get v, and I'm differentiating the force, which is u, so I'll have u prime. So I differentiated the force, which is this, that's why I have u prime, and I leave the second, which is v. So v function comes back there. Are you following?
Yes, sir.
Anyone else? You see the v function comes back, so I leave it. That was my second function, but the first function is u, but I differentiated it. That's why I have u prime. So I differentiated the first and I left the second. Is that clear?
Yes, sir.
Come on, someone else say something, please.
Yes, sir.
Right? And what we do the opposite for the second. So if I differentiated v and I differentiated u and I left v, what do you think we'll do here now?
Sir, you differentiate the v and left the u.
Very good. So I'm going to start with u now times the derivative of v. So basically this is how we get the product rule. Differentiate the first, leave the second, and then you do the opposite. Differentiate the second, leave the first. Is this good with everyone?
Yes, sir.
Right. So as you can see here, teachers, we need 4 things to substitute here. 1, 2, 3, 4. So far, we only have 2 functions. We know what u is equal to. U is equal to 5x, and we know what v is equal to. V is equal to 4x squared minus 1. So I would like Basmati to tell me what the derivative of u will be. If we differentiate u, what will we get? Come on, multiply by the power, take 1 from the power. Basmati?
Hi, sir.
Yes, I'm asking, if we find the derivative of 5x, multiply by the power, take 1 from the power, what will that be? We're trying to find the derivative of u using the power rule. Multiply by the power, take 1 from the power. Let's go. What will we get? You there with us, Basmati?
Sir, just a second. I'm trying to. Just give me 1 second. Trying to get the transcript.
You have the coefficient 5. What will you do?
5 times the power.
Good. So we get 5.
Which will give
Great.
5.
What will you do next?
Oh no. So x to the power 1 minus 1.
Great. So that's all I wanted.
Yeah.
You multiply by the power, you subtract. Don't forget the rule, that's it. So what will happen here now? 1 minus 1, what will we get?
0. So it will be
Yeah, go ahead, I'm listening. We have x is 0 power, so that will give you.
that will give you 1. So it will be 5.
Great, wonderful. So by now you should see when you find the derivative of a function that is raised to the first power, you'll just get a constant. Okay? So your answer is actually just 5. Is this good with everyone?
Yes, sir.
Yes, no? Right? If we have 6x and we find the derivative of 6x, what will it be?
6, sir.
6, yeah. So the derivative of 5x is actually 5. Are we good so far?
Yes, sir.
Alright, so Anoop, what will be the derivative of v?
V, which is 4x squared minus 1.
Yes,
So
apply the rule.
V by 4, 8x minus 0. Yeah.
Great. So it's 8x, right? Once you have a constant, the constant will become 0. So are we good with that? Are we good with that?
Good.
Yeah, so this is basically what you have to do. When you have the product rule, you just need to take the two functions and find their derivative. Are we clear so far?
Yes, sir.
And all we need to do now is to plug them into the formula. This is not something you have to remember to derive. You just have to get the formula and plug in the values. So every time you hear product rule, just remember the formula and put in the values. So let's go putting in the values. The derivative of the product is equal to, where I have v, what will I do?
So 4x squared minus 1.
4x squared minus 1. Someone else, what's the next thing we're substituting for? We're finished with v. What's next?
5, so that will be 5.
Very good. So the derivative of u is 5. So I put 5 there. Next. Someone else. Come on, let's go.
Plus 5x.
Very good. U is 5x. Wonderful. Next. Someone else.
Plus 8x.
8x.
Plus 8 times 8x. Wonderful. So let's go ahead and simplify. Let's simplify and see what we'll get. So I'll give you 1 minute to simplify this multiplied by this multiplied by this, and then you see what common terms. So you have 1 minute to simplify. X squared minus 5. Now let me just say something to you. This is the answer. Is that clear to everyone? When you substitute here, this is the answer. Just let me know that you're clear.
Yes, sir.
Everything else is your ability now to simplify. So if you're finding a difficulty to simplify, don't say that this thing is hard. That's something I want to put out here. Once you substitute, you have your answer. This is the answer. But now we're trying to neaten it up. Right? So this would be 5 plus 5 is 40x squared. Can we combine anything there?
Yes, sir. We group the 20x and the 40.
Great. So you have 60x
Squared
squared minus 5. And that's basically your answer. So you see, all we had to do, you know the formula because you will be given you won't be given the formula in the exam, but through using the formula, you will remember it, that you differentiate the first one and keep the second one. You'll remember the rule. Make sure you have your 4 things to substitute, and when you substitute, you have your answer. That's basically the quotient, the product rule. Are we good there?
Yes, sir.
So
Yes,
what I wanted you to see though, why I use this one here, I want you to see that the answer is legitimate. So look back at this function. Y is equal to 5x into 4x squared minus 1. The truth is, I could expand this. So this is 5 fours 20 x cubed. Am I correct?
yes, sir.
Yes, sir.
And
Minus
5x by 1 would be 5x.
5.
Great. So this is the same function. I just simplified it. Now I can go ahead and find the derivative. I deliberately use this function because I wanted to do this to show you that your answer is correct. Right? So using the power rule, 3 times 20 will give us what?
60x squared, sir.
Good. 60, and we take 1 from the power, so it will be 60x squared. And 5x, when we find the derivative of 5x, what will we get?
Minus 5, sir.
Minus 5, right? You multiply by the power 1, you take 1 from the power, you will end up with just 5. So look here. Good. So is this good with everyone?
Yes, sir.
I just did this to show you, right, that the product rule is legitimate. Usually you won't get a function like this to do the product rule. It will be one where you can't multiply like this. So you have to take the product. You have to use the rule. But I deliberately use this just so that I can prove back the answer to you. I'm just trying to show you how all of these things are connected. Good. Would you like to try one? Yes, no?
Yes, sir.
Right, so I'll give you another simple one that you can check back, just for you to practice the rule. Differentiate the first, leave the second. So I'll give you a simple one that you can check back. One that shouldn't take long to do either. Because I really want you to get the practice. So let's say y is equal to x squared into 5x minus 1. So you decide which is your u, which is your v, and go ahead.
Sir, x squared.
All right, so someone else, what did you put as v then? Come on, let's talk.
5x minus 1.
Great, 5x minus 1. Now, according to the formula, we need the derivative of u and the derivative of v. Basically, we need to differentiate both of them. So someone else, when we differentiate u, what do we get? That x squared. When we differentiate it, what is our
2x
answer?
sir.
2x.
Wonderful, 2x. And when we differentiate 5x minus 1, what do we get?
5.
5, wonderful. So all we need to do now, our answer is our substitution. That's basically it. So let's go. Someone give me, where I have v, what do I put?
So 5x,
5x
minus
minus
1.
5x minus 1.
Wonderful. 5x minus 1, what comes next?
By the derivative of u, which is 2x.
2x
Wonderful. Plus
Plus u
x squared.
squared
wonderful. And finally,
by 5, the derivative of
wonderful. So basically, this is your answer. That's all you need to do. Anything after this is simplification. That's the product rule for you. It's just to neaten up your answer after this. So 5 to 10x squared minus 2x plus, I don't know why the x is coming out like this, plus 5x squared. So you should have, what's your final answer?
Being 105x squared. So 105x
I got 15x
squared.
squared minus 2x when I simplify.
Sorry, just go that over, please.
We're talking about, sir, when you simplify.
Yeah, your final answer.
I got 15x squared minus 2x.
Wonderful, that's it. 15x squared, because we put these two together.
Oh, yeah.
So you get 15x squared
Minus 2x.
minus 2x. Right, so that's basically what it should be. And if you check back the other way, you should get this as your answer, right?
Yes, sir.
All right. So that's the product rule for you. Any questions pertaining to the product rule? Yes, no?